Hi dear friends, welcome back. In this video we are going to discuss about the acceleration, motion in one dimension. When a body is moving along particular one axis, then how the acceleration is going to be calculated. First thing, we have to know what is acceleration and what are the dimension formula and units of the acceleration, and how many types of accelerations are there, and what are the directions of velocity and accelerations. We have to discuss all these things. Along with them, we have to discuss about some problems related to the acceleration in case of motion in one dimension. That's why, to understand the subject very clearly, you have to watch the video up to last. This is the fourth video of the kinematics chapter. I will provide the playlist in the end cards, then you can click them and watch the remaining videos also. Clear, children? So without late, we are going to the topic. What is acceleration? The rate of change of velocity is called acceleration. Acceleration should be here vector quantity. Rate of change of velocity. Rate of change of velocity is called acceleration. Is called acceleration. And here we will write the formula should be like this: A is equals to change in velocity. Change in velocity by time. This is the formula for general formula for acceleration, change in velocity for time. For example, it is a one straight line, horizontal line. On that one car is traveling like this, and that should be having some initial velocity u, and after moving some time t, its velocity becomes v. U is the initial and v is the final. Clear? Then in this case, what read? A is equals to final velocity minus initial velocity by time we are taken. Therefore A is equals to what here? Nothing but v minus u by t. A is equals to v minus u by t. Here change in velocity is vector quantity, that's why acceleration also a vector quantity. And now in this case, here we have units are there for acceleration. In CGS, centimeter per second square, and SI, meter per second square. Meter per second square. And the dimensional formula we can write what is v minus u. V minus u nothing but change in velocity. Velocity dimension formula is what? LT inverse 1 by time t. That's what already here. LT inverse 2. LT inverse 2 is the dimension formula of the acceleration. So we can explain the acceleration of the body only on the basis of change in velocity. Change in velocity. Clear? If the change in velocity is positive, acceleration is positive. If change in velocity is negative, acceleration also negative. If change in velocity is 0, then acceleration also 0. If change in velocity is negative, acceleration is negative. Got it? Based on the change in velocity only we can explain the acceleration. Here when change in velocity is a vector, acceleration also vector. When change in velocity is positive, acceleration is said to be positive. When change in velocity is negative, acceleration is negative. When change in velocity is 0, acceleration is 0. When change in velocity is negative, that is negative acceleration. Negative acceleration also called as retardation. So we will discuss all these definitions in detail. Let's discuss about the what is mean by non-uniform acceleration. What is mean by non-uniform acceleration? Already we discussed what it is. Acceleration is a vector quantity. In case of a vector, if magnitude or direction, among these if any one of the changes, then it is also changes. Got my point? Acceleration is a vector. Vector has both magnitude and direction. If both magnitude and direction changes, then velocity changes. When velocity changes, acceleration is there. Among these two, if any one of them, if magnitude changes, then also velocity changes. When velocity changes, acceleration also changes. That's why here, when a body is in motion, if the velocity is changes with respect to time, whether it is in magnitude or direction or both, then the body is said to be have acceleration. Clear? When change in velocity is positive, the acceleration is said to be positive. Clear? Here, what is the non-uniform motion, non-uniform acceleration? If the change in velocity is changes with respect to time, then the acceleration is said to be non-uniform acceleration. When a change in velocity changes, if the velocity magnitude or velocity direction or both magnitude and direction of velocity both can be changes, then acceleration is changes. Clear? You have to remember simply what is meant by non-uniform acceleration. If the change in velocity of the body changes with respect to time, then that is what you have to say, non-uniform acceleration. Here, under the non-uniform acceleration, we will discuss about the positive acceleration and negative acceleration. What is meant by positive acceleration? If the velocity of the body is increased with respect to the time, then the acceleration of the body is said to be positive. Clear? If the velocity of the body is changes with respect to the time, how velocity is increased with time. For example, one bike it is there. If we can change the gears, we are increasing the gears, then obviously the speed of the bike should be increases. Then the acceleration of the vehicle is said to be positive acceleration. Clear? To understand that, here I am giving one example to you. Positive acceleration. What is positive acceleration? If the velocity is changes with respect to time, then the body have positive acceleration. For example, here in this one, car is at time t is equals to 0 seconds, its speed is 0 meter per second. After 5 seconds, its velocity is 20 meter per second. Now, what is change in velocity here? 20 meter per second. 20 meter per second. And time interval is what? 5 minus 0, 5 seconds. And next interval also 5. Then the speed is change in velocity is what? 50 minus 20, 30 meter per second. Clear? So again what you have to say here, 70 minus 50, 20. Here it is again 5. 90 minus 70, 20. Again here 110 minus 90, 20. And here 5, 5, 5. At every time of interval is what? As equal intervals of time, but here unequal change in velocities, that's why it is what you have to say, non-uniform acceleration. Dear students, you can observe here, at every time change in velocity is positive, that's why it is having the positive acceleration. The car speed is increased. Initially how much it is there? 0 meter per second, next 20 meter per second, next 50, next 70, next 90, next 100, like that, 110, like that. The velocity is increased, the magnitude is increased, and at the same time it is moving along the straight line path. That's why here direction is same. In this case direction is same, but what it changes? The magnitude of velocity is changes. Initially 0, next 20, next 50, next 70, next 90, and 110, like that. So in this case what you have to say, already we know what it is. A means here change in velocity for time. You can observe in any time of interval here we are getting the positive value of change in velocity. Initially 20 minus 0, 20, 50 minus 20, 30, 70 minus 50, 20, 90 minus, like that. Every time we are getting the positive change in velocity. That's why the acceleration is said to be positive. And is coming under the non-uniform acceleration. And next thing here, children, Negative acceleration. Just now only we discussed what is, if the speed is continuously increased, that acceleration is what? Positive acceleration. Why? Because the change in velocity is positive. Clear? For example, if we are moving on the bike, we are on the 4th gear, nearly we are moving on the speed of 80 km per hour. When suddenly we are going to be decrease the gears, obviously its speed is decrease, velocity is decrease, then the change in velocity is negative and the acceleration is called negative acceleration. When the velocity, the magnitude of velocity is decreased with respect to the time, then the acceleration is said to be negative acceleration. Look here, in this case we are taking initial it is having some velocity 120, and next for next time interval, next time 80, next 60, next 50, 20, 15 like that. So every time we are observing the time of interval is 5 for equal interval of times, for equal intervals of time. 10 minus 5, as like this we can take 15, 20, 25 like that. So but here changing velocity is what? 80 minus 120 minus 40, and in this case 60 minus 80 is minus 20, and now 50 minus 60 minus 10, and 20 minus 50 minus 30, and again 15 minus 20 is minus 5 meter per second. So all are here velocities. So in this case, initially the velocity of the car is here 120 meter per second, and with very short time it is going to be decrease its speed. That's why here in this case also the vehicle is moving along the straight line path, but there is no change in direction. But where is the difference here? The magnitude of velocity is changes. That is what? Decreases. When it decreases, we are getting the change in velocity is negative. When change in velocity is negative, acceleration also negative. That's why here this is the negative acceleration. Negative acceleration also called as retardation or deceleration. So that is simply about the negative acceleration. You can observe here in both cases the change in velocity is not uniform. It is non-uniform. That's why it is non-uniform acceleration. Clear? And we are taking equal intervals of time t1, t3, t4 and t5 and so on like that. Every time what you are taking some, what there may be here, this is the time of interval that should be taken as here. I am going to say that is 10 seconds, 10 seconds, 10 seconds and again 10 seconds, 10 seconds. In this case here, now 20, 30, 40 meter per second and 50 meter per second, 60 and 70. Clear? When the body can covers equal change in velocities, here 10 seconds is the time interval, then change in velocity is what? 30 minus 20, 10 meter per second. Here 40 minus 30, 10 meter per second. Here 50 s 10 meter per second. Again here 10 meter per second. Again here 10 meter per second. It means that what? The body can covers equal change in velocities in equal intervals of time. Then the body is said to be in uniform acceleration. Here the body is maybe anything like here object, like it is the particle object, like anything vehicle or man or any person should be taken as like that. If the body can covers equal change in velocities in equal intervals of time, then what you have to say? The body is having uniform acceleration. So already just now only we discussed what it is. If your body is falling down under the gravity, it is having some uniform acceleration. When the body's velocity is increased with respect to time, and when the velocity of the body is decreased with time, then the body has non-uniform acceleration. And now when the acceleration becomes zero, acceleration becomes zero. So obviously when the body is moving with the same magnitude of velocity, if the body is moving with the same magnitude of velocity, then acceleration becomes zero. To understand that, simply here we are saying now t1, t2, t3, t4 and t5 like that. At every time that should be having some same magnitude of velocity, 50 meter per second, 50 meter per second, 50 meter per second, again 50 meter per second. So at every time that is having same magnitude of velocity, what is 50 meter per second, 50 meter per second. Then obviously what you observed here, 50 minus 50, yes, 0. What we know, a is equals to what? Acceleration is equals to change in velocity for time. In this case, for every time of interval, time never be 0, but here change in velocity is 0, that's why here acceleration is 0. Clear? When a body or particle is moving with the constant magnitude of velocity, then its acceleration becomes 0. So dear students, this is about the what is non-uniform acceleration, uniform acceleration, and when the acceleration becomes 0. Dear students, here you have to know under 3 conditions only change in velocity takes place. There are 3 possible ways by change in velocity occur. The first thing is here when direction of velocity changes. Direction of velocity can changes. So for example, for this one, here we can take some circular motion. So we have to assume that a particle is moving along the circular path. So even though magnitude of velocity is same everywhere, for example we are saying now 30 meter per second, 30 meter per second and 30 meter per second, like that. Clear? Every time what you have? At every point when the particle is executing the circular motion along the circular path, at every point its magnitude is same, but its velocity is changes. How it is possible? If you can draw one tangent line that will use the direction of velocity. So when direction changes, then velocity also changes. When velocity changes, acceleration is possible. Clear? Even though the magnitude of velocity is same along the circular path, but its direction is changes. If you can draw a tangent line on the circular path, that should give the direction of velocity. That's why here there is some, when direction of velocity changes, change in velocity takes place. Change in velocity takes place. In this case, velocity and acceleration both are perpendicular to each other. When a particle is in circular motion, when its change in velocity takes place. Change in velocity means what? Acceleration is there. At this situation or for this situation, the acceleration and velocity both are in perpendicular to each other. So velocity and acceleration perpendicular to each other. That is the first thing. And second one is when direction of velocity changes, we said when direction of velocity changes only. And second one, when magnitude of velocity changes. In this case here, direction of velocity changes, magnitude is constant. For the second case, the magnitude of velocity changes but direction is constant. In this case also change in velocity takes place. That's why the body can experience the acceleration. For this best example is a freely falling body or a vertically projected body. For a freely falling body, initial velocity is 0 and when it comes downwards, its velocity is increases. Clear? And now when the body is vertically projected, its change in velocity is in s. Here the velocity is in upward and acceleration due to gravity is in downward. Clear? That's why here when the body comes down along a straight line path, when the body is moving along the vertical path or straight line path in vertically, then obviously the velocity magnitude changes. But here vertically projected body and freely falling body, it is moving along the only one particular y-axis only. So that's why it is straight line. When it is straight line, it has same direction, but when it is moves along the straight line path, there is no change in direction, but velocity can changes because the motion of the body is under the gravity. Clear? So in this case also velocity can changes, due to that the body can experience the acceleration due to gravity. In this case, acceleration and velocity are parallel or anti-parallel. This is another situation when magnitude of velocity changes but direction is constant. At this for this situation, acceleration and velocity all are in parallel to each other or anti-parallel to each other. That is the second condition. And third one, in case of projectile motion, of a body, in this case velocity magnitude changes and direction also changes. For the first time, what we consider, only direction changes. For the second example, what we discussed, only magnitude can changes. But for the third condition, if the magnitude and direction as well as magnitude and direction both are changes, then also change in velocity takes place. For that example here, what is that condition? If the magnitude and direction of body can change. That is possible when in case of a body can move in a plane, we are taking it is projectile motion. So in this case here we have velocity is divided into two components like this, ux and this is uy and this is ux. So at this point acceleration is parallel to the one thing and perpendicular to the another one. So it is the horizontal component and the direction of acceleration to the right should be like this. Then what you have to say here, for this ui it is parallel, anti-parallel, and for this ux it is perpendicular. Clear? In case of projectile motion, acceleration of the body is parallel to the one velocity component and perpendicular to the another velocity component. So dear students, the velocity of change or change in velocity can be takes place based on these three things. When velocity changes, obviously the body can experience the acceleration. I want to clarify one thing. What is the difference between average acceleration and instantaneous acceleration? What is average acceleration and what is instantaneous acceleration? So this acceleration, how we can define it, means that the ratio of the total change in velocity in particular time of interval, that should be what we call average acceleration. Average acceleration can be shown by the formula A average is equals to total change in velocity by time taken. When the body is moving with the non-uniform acceleration, we are going to use this formula. Sometimes maybe acceleration increase, sometimes maybe acceleration is decrease. That is purely depend upon this formula. What you have to say, change in velocity can decide, total change in velocity can decide the average acceleration. If total change in velocity is 0, average acceleration also 0. If total change in velocity is positive, average acceleration is positive. If total change in velocity is negative, average acceleration also negative. So that is the you have to remember. And here for example we have one case, it is there in the time t1 when the body is in motion. For the time t1, that is having some acceleration a1, and for the time t2 the acceleration should be taken as a2. The time t2 the acceleration is a2, like that. So we can use that one. Here formula is here average acceleration is the nothing but a1 t1 plus a2 t2 by a1 t1 plus t2. Clear? So how we can write? A is equals to v minus u by t. Then v minus u, what is nothing but change in velocity. Change in velocity is equals to what, right? At here. Clear? That's why here what, right? A1 T1 plus A2 T2 by T1 plus T2 we can write. This is the formula you are using the when the acceleration changes with the time. So this is simply about the what is average acceleration. And now instantaneous acceleration. Instantaneous acceleration. Instantaneous acceleration means the acceleration of the body at particular instant of time is called instantaneous acceleration. The acceleration of the body at particular instant of time is what we call instantaneous acceleration. It should be shown with formula like this: limit delta t tends to 0, delta v by delta t, delta v by delta t. So this is what instantaneous acceleration, and that should be written as here nothing but dv by dt. What is dv by dt? Therefore we can write like this also: a is equals to dv by dt we can write, and for our convenience we are multiplying the numerator and denominator to dx. Then there is no change in value of that particular dv by dt. So dv by dx into dx by dt. So then what you have to write? dv by dx into dx by dt. Here dx by dt means what? Nothing but velocity. Nothing but velocity. Therefore what did here? A is equals to v into dv by dx. This is another form of formula for instantaneous acceleration. Clear? See one problem. At time t is equals to 0 seconds, velocity of a particle is v1 is equals to 2I minus 3j meter per second, and at t is equals to 10 seconds, velocity is v2 is equals to 4I minus 2j meter per second. Find the average acceleration in the given time interval. So what you have to find out? We have to find out the average acceleration. So we want to find out the average acceleration. We have formula is there. What is total change in velocity? Total change in velocity. Total change in velocity for total time taken. Total time taken. Clear? That is because what right here simply v2 minus v1 is the total change in velocity, and t2 minus t1 is the total time taken. That is more simply what right here? Delta v by delta t. So therefore A average is equals to what you have? Simply what is v2? 4I minus 2j minus of 2I minus 3j by t2 is what? 10 seconds, and t1 is what? 0 seconds. 10 minus 0. That is what here? 4I minus 2j plus minus 2j minus 2I plus minus of minus plus 3j by 10. Then what is 4I minus 2I? 4I minus 2I minus 2j plus 3j by 10. So 4I minus 2I, 2I minus 2j plus 3j plus j by 10. And that is equals what? A average is equals to simply 2 by 10. 2 by 10 I plus 1 by 10 j. That is equals what? 0.2 I plus 0.1 j. So this is the average acceleration. Clear? Let's see another problem. The relation between time and distance is t is equals to alpha x square plus beta x, where alpha and beta are constants. The retardation means what? Negative acceleration. The relation between time and distance is given by the what is t is equals to alpha x square plus beta x, where alpha and beta are constants. The retardation is, some options are given. First option is 2 alpha v cube, 2 beta v cube, 2 alpha beta v cube, 2 beta square v cube. That is the options are given. So here first you have to know what is acceleration. Acceleration is what? Nothing but dv by dt. A is equals to dv by dt, and A is equals to, we will write like this: dv by dx into dx by dt we can write. Then what is A is equals to dv by dx into, this is v, So you have to remember this one. Clear? And now if x is the distance, then the velocity is what? Dx by dt. V is equals to what? Dx by dt. And a is equals to what, right? D square x by dt square we can write. So this is a simple idea about the acceleration, relation between the acceleration and displacements, like that. So we are going to use the same formulas here. Now what he was given, t is equals to alpha x square plus beta x, he was given. It's very clear. From that, what right here I am going to write the equation is in form of x, the function of x. That's why we have to differentiate with respect of x. dt by dx is equals to d by dt of alpha x square plus beta x. Clear? So we have one formula is there. What is d by dx of x to the power of n is equals to n into x to the power of minus 1. Formula it is there. And what he was mentioned, alpha and beta are constants. Then what is here? dt by dx is equals to here alpha into here x square 2 into x to the power of 2 minus 1 plus beta into d by dx of x. Clear? Then dt by dx is equals to what? Here what is right? 2x to the power of minus 1 means what? 1 only. 2x alpha plus beta. So this is what? Dt by dx. I am going to write like this. Dx by dt is equals to here what, right? 1 by 2x alpha plus beta we can write. So already what we discussed, dx by dt is what? Velocity. That's why here we have what it is? Dx by dt is equals to 1 by 2x alpha plus beta we have. Clear? Then it is equals to 1 by 2x alpha plus beta. So already we know that what it is, v is equals to dx by dt. Rate of change of displacement, what we call? Velocity. That's why here what, right? v is equals to 1 by 2x alpha plus beta we have. And the should be written as here nothing but v is equals to 2x alpha plus beta whole to the power of minus 1 we have. So but what you have to find out? We have to find out the retardation. That's why here we are going to use this formula. A is equals to dv by dx of v. Then for a is equals to v of here d by dx of what is v value? 2x alpha plus beta whole to the power of minus 1. Then obviously it is quite similar to d by dx of x to the power of n. That is what? N into x to the power of n minus 1. Here what is n value? Minus 1. A is equals to minus 1 into v of 2x alpha plus beta whole to the power of minus 1 minus 1. And for this 2x alpha, what do you write here? 2 alpha. Therefore a is equals to minus 2 alpha v. And this is what? 2x alpha plus beta whole to the power of minus 2. And the same thing can be written as minus 2 alpha v, and it should be written as 1 by 2x alpha plus beta whole square we have. And what is v value? V is equals to 1 by 2x alpha plus beta. Then v square means what? 1 square by this one. That's why here simply a is equals to minus 2 alpha into v into, I am going to write like this, v square. Then obviously what you can write? A is equals to minus 2 alpha into v square. Then a is equals to minus 2 alpha v cube. So this is the negative acceleration, that is what? Retardation. That's why here 2 alpha v cube, first option is the correct one. Let's see another problem. A particle is moving along the x-axis. The x-coordinate of the particle varies with time as x is equals to 3d cube plus 4d square minus 6. Here x is in meters, t in seconds. Find the instantaneous acceleration of the particle at t is equals to 0, or t is equals 1 second, and average acceleration in a time of interval from t is equals 0 seconds to t is equals to 2 seconds. So what he was given? A particle is moving along the x-axis. One particle is moving horizontally, and its displacement is given by the equation x is equals to 3t cube plus 4t square minus 6 in terms of time, function of time. And what you have to find out? We have to find out the instantaneous velocity at the time of t is equals to 1 second. We want to find out the instantaneous acceleration and average acceleration. That is the problem here. So what we know, if x is the displacement, then v is equals to what? D by dt of x. Clear? And a is equals to what? D square x by dt square. This is the formula we have to remember. So now I am going to write here, first thing, v is equals to d by dt of x. That is what? D by dt of 3t cube plus 4t square minus 6. So what we know, d by dx of x to the power of n is equals to what? N into x to the power of minus 1, like that. Then v is equals to here 3 into 3 t to the power of 3 minus 1 plus 4 into 4 into 2 into t to the power of 2 minus 1, and it is a constant, just there is no differentiation. Then v is equals to what? 3 into 3, 27 t square plus 4 into 2, 8, and t to the power of minus 1, 8t. So what is v is equals to 27 t square plus 8t. Then what is here? A is equals to d by dt of v, that is equals to what? D square x by dt square. That's why here I am going to write d by dt of v. A is equals to what? A is equal to d by dt of v. What is v here? 27 t square. Oh, sorry. 3 into 3, not 3 cube, 3 into 3, 9 t square plus 4 into 8, 9 t square plus 8. So here what, right? 9t square plus 8t, 9t square plus 8t. Then what did I here? A is equals to, again same formula, 9 into 2 into t to the power of 2 minus 1 plus 8 into 1. Then A is equals to what? 18t plus 8, 18t plus 8. That is the acceleration in terms of time. And first what you will find out, instantaneous acceleration at t is equals to 1. At t is equals to 1 second, what is? A is equals to 18 into 1 plus 8. That is what? 26 meter per second square. That is the instantaneous acceleration. Equals 26 meter per second square. Now what you have to find out? Second one is average acceleration. We have to find out it. So already what we know, acceleration average is equals to delta v by delta t. That means what? A average is equals to v2 minus v1 by t2 minus t1. This is the formula we are going to use. Clear? So we need some space, that's why I am erasing this one. Okay, so first thing is here, what is v1 here? That is nothing but at the time of t is equals to 0. At the time of t is equals to 0, what you have? v1 is there. What we got v1 formula? 9t square plus 8 into t, 8 into t. Then obviously what you get here? v1 is equals to 9 into 0 square plus 8 into 0, that is what? 0. And similarly here now, v2, what is at the time of 2 seconds? Then what are here? 9 into 2 square plus 8 into 2. That means what here? v2 is equals to 9 into 4 plus 16. So 36 plus 16. That is what? 52 meter per second. 52 meter per second. That is what? v2. So what we need actually, what you want to find out? Average acceleration. Average acceleration. A average is equals to v2 minus v1. What is v2? 52 minus 0 by t2 minus t1. 2 minus 0. So 52 by 2, that is what? 26 meter per second square. Meter per second square. This is the average acceleration. You can observe here, average acceleration and instantaneous both are same here. Friends, so if you can understand the concept of what I was explaining in this video, then please subscribe my channel and press the bell icon too. And my request is share my channel to your friends also. Thank you for watching. And if you want to write the online exams, then download the app Nonuniform Basics of Physics from Google Play Store. Thank you.